Good morning. In this video lecture, we are going to see the next topic, that is loader. So, what is a loader? Loader means we have already discussed about assemblers. So, what was an assembler? Assembler was a system software which was used to convert your program or assembly level program into machine understandable form. So, I had a program, now it is understandable by their machine, so it was just translated to in another form. Now, the program has to be loaded into memory for execution. So, if you want to load a program into memory, you require a loader. So, loader is something which will load your machine understandable program into memory for execution. So, there are three types of loader we are going to see today. First one is a absolute loader. Second one is a bootstrap loader, and the third one is a relocatable loader. So, as I have already said, loader is something which will load your program. It will not load the user program, instead it will load the machine understandable program, that is the program which is compiled or the program which is assembled into a machine understandable form, that is in the form of zeros and ones. That program or your object program will be loaded into the memory location. So, it will load the program into RAM for execution. So, your program will always require a memory to run. So, we will allocate the memory or we will load the program into the specified memory location, then the program will be executed. For this, we require an absolute loader, then next one is a bootstrap loader, third one is a relocatable loader. First, we will see what is an absolute loader. So, listen, absolute loader in the sense, it will load in the absolute position. For example, it will load in the absolute position in the sense, suppose if I write a program, copy start 1000, in the sense I have a program, the name of the program is copy, this is the starting of the program, the starting address is 1000. That means the first instruction will start at location 1000. The remaining instructions will follow this. So, the program starting address is 1000. So, if I write a program and it starts at 1000, I am telling that this program will start at 1000. I can load this program only at the memory location 1000. If the program is loaded only at the location specified by the user, then it is called as absolute loader. So, absolute loader will load your program in the exact location specified by the user. So, if a user has specified a location as 0000, the program will start at 0. If the user has specified as 1000, it will start at 1000 or it will be loaded at 1000. If the program is specified as 2072, the program will start at 2007. So, it will load only at the location specified by the user. So, here what is an absolute loader? It will load your program into the location specified by the user. For this, we will see an example. Consider this is an object program. So, object program will contain header record, text record and end record. Here we have specified two text records. For example, we have an end record. So, end will specify the starting address of the program. Header also will specify the starting address of the program. Here you can see H copy means name of the program. This 1000 specifies the starting address and this specifies the length of the program, which we have already discussed in the previous video lectures. So, now how does an absolute loader works? Now listen, I will write the memory location and we will see the contents, how these contents are placed in the memory. For example, first memory location is 0000, second location is 00010. Similarly, you have memory locations. Suppose this location is 1000. I will specify this is the 1000th memory location. So, our program starts at 1000 location and the first object code is 141033. Now, you have to specify This is an SiC program. We have already discussed in SiC and SiC-XE. The SiC, the memory is divided as 8-bit bytes. So it is specified as an 8-bit bytes. So here you have specified only 6 bits. So I can add 2 more things. So from the next one, 48. So this is the first memory location. It will contain 141033, which is 6 bits, and the next 2. So the next one will be 2039, another 4, 0010. So 1000 location, 1001, 1002, 1003, 1004, 1005, 1006 and 1007. So next, after 100010, next one will be 36, then 281030. Next one will be 301015, then it will be 48. Now after that, you can see here, this is a location 1000, 1001, these two will be 1002, and this is 1003 location, 1004, 1005, 1006, 1007, 1008, 1009, then it will be 100A, then B, then C, D, E and F. So the next memory location will be 1010. So from location 1000 to 100F, all these values are arranged, and next one will be from 1010. So we have written till this one. So the next 1010 will contain 2061, then the next one 3C. So we have only specified 6, 2 more can be specified, 10. The next one will be specified as 030010. Then next will be 2A. Similarly, all the text records data will be specified only at the location specified by the user. For example, so all the text records will be written. Suppose if you come down, suppose your text record is 2070. So this text record will start from 2073. So 70 will contain some data, 71 will contain, 72 will contain. So 73 is this location. So this location will contain 38. So the next one will be 2064, then 4C00. You can see. So this is how an absolute loader works. An absolute loader will work in the form that is, if I have specified something in my text record, or if I have specified something in my object program, wherever I have given it as a starting address, only at that starting location my program will run. In the remaining places my program will not run. So my program will be loaded only at the memory location specified by the user. So next we will see the second type, that is a Bootstrap Loader. What is a Bootstrap Loader? Now listen, Bootstrap Loader in the sense, so when I am switching off my computer, or I am restarting my computer, or when I am turning on my computer or restarting my computer, no program will run, but operating system will initialize and it will give me a welcome screen, or it will give me a place for typing my username or password. So how does this work? So for this operating system to initialize, Bootstrap is a loader. So Bootstrap Loader is the first program that works when you turn on or restart your computer. So if I restart my computer or if I turn on my computer, that's a first program that will run or that will initialize, so that my operating system will be loaded and it will make my computer ready for execution. So to make my computer ready for the execution, I am using something called as a Bootstrap Loader. So we have seen 2 loaders, and the third one is Relocatable Loader. So what is a relocatable loader? So relocatable loader in the sense, we have already seen the concept of relocation when we are discussing about the machine dependent assembler features. So today again we are going to see the same concept. So we have relocation, So what is relocation? If I have specified a memory, the starting address is 1000 and the memory 1000 is preoccupied by some other program, I cannot run the program. So suppose memory location at 2500 is ready, I have to relocate my program from 1000 to 2500, and this concept is called as relocation. Some instructions requires relocation, and for example, we have already seen format 4 instruction requires relocation because it depends only on memory, but format 3 instructions will not require relocation because these memory things will be just, for example, if I am running from 1000, some instruction will be 0 2D locations away. If I am running from 2500, same instruction will be 0 2D locations away. So these instruction, format 3 will not require relocation, but format 4 will require relocation, and for that format 4 request, what we did is we have studied a new thing called as modification record. So what is modification record? That is, we will write at the location which will be modified. Here modification record M we will write, then for example if it is 007, that is the location that will be modified, and how much will be modified. For example, format 4 we can see like this. This is your format 4 instruction. Format 4 instruction will contain an opcode, and then it will contain NIXBPE, NIXBPE. So here we will have the location. This will be modified. So it is 20 bits. I have to represent this by means of half bits. So 20 divided by 4. When you are dividing half bits, you have to divide by 4, which you will get 5. So I will represent as 05. This location, that is from the location 0007, I have to modify for 5 half bits. So here in this loader, I have to specify the name of the program. So the name of the program is copy program. I will add plus copy. This is specified because the loader has to check where. That is, if my program starts from 1000 as it is written in the program, there is no need to write it. But if my program starts at 2500, I should know the relocated address. So I am specifying it as copy. So if I specify as copy, if the program starts from 2500, my relocation will adjust in such a way that it is going to check from 2500. If my program starts from 3800, this copy will specify the value is 3800. So accordingly, this value will be relocated. This is how a relocatable loader will work. And another one thing, this is for an SiSi XE program. Suppose if your program is an SiC program. So if my program is an SiC program, there will not be any modification record because there is only one type of addressing here. Direct addressing is there as well as index addressing is there. But in the case of SiC XE, I will have lot of addressing modes like index addressing mode, immediate addressing mode, format 4, all these things will be there. But in the case of SiC, I will have only a direct addressing and index addressing mode. Here there will be no need for modification, but there are chances for relocation. So how that will work, I will tell. If a program starts at location 1000, consider there is an instruction like this, 141033. 141033 is the value for STL RETADR. This specifies that STL value is 14 and RETADR is at location 1033 if my program starts at 1000. But if my program starts at location 2000, then the same instruction will be written as 142033. If my program starts at 000, my instruction will be written as 140033. So you can see that one bit will be relocated. So relocation takes place. For this relocation in relocatable loader, what we will do is we will use a bit called as mask bit. Mask bit. So what is mask bit? Mask bit is a 3-bit value where I will write as, for example, each bit is represented by or represented in 4 bits. For example, it's a 3-byte value. It is represented by, for example, if I have 3 bits like this, the maximum value you can have is F. So F can be written as in 8421 method 8421 if all the bits are 1. 8 plus 4 plus 12, 14, 15. 15 is represented as F. Again 1, 1, 1, 1 and another 3, it will be 1, 1, 1, 1. So 3 values. F, maximum value can be F. So how does this works with the relocation? Now consider this text record. In this text record, the first record, if it points to an address, this will be modified. If an instruction is to be modified, I can specify as 1, and if an instruction will not be modified, I will specify as 0. So first will be modified, second will be modified, third, fourth, fifth, 6, 7, 8, 9, 10. All the 10 bits will be modified. So max you can have 12. The first 10 will be modified. If the first 10 will be modified, I will write like 8, 9, 10. Next will be 0, 0. So it will be F, and this one will be F, and the remaining will be C. So along with this text record, so I'll write the text record like this: text, that starting address 0, 0, 1, 0, 0, 0. Then I will specify 1E, that is the length of the text record. Then I will represent the mask bit. The mask bit for the first one is F, C. 8 plus 4, 12, that is C. Then I will write my text records, that is object codes. This is how a mask bit works. Suppose if I have a next text record which will have only 3 values, 3 object codes actually, 1, 2 and 3. All these 3 places will have 1. That means first 3 places will have 1, then the remaining all places will be 0. That means I can specify as 842, that is 12 plus 2, 14. 14 means it will be E. Then the remaining places are 0, E 0, 0. So second text record will have the value as E 0, 0. So in this video lecture, we have learned about an loader. What is a loader? Loader is something which will load your object program into memory for execution. There are 3 types of loader we have discussed. First one is an absolute loader, which will load your program in the absolute location specified by the user. Second one was a bootstrap loader. What is a bootstrap loader? Bootstrap loader will load the operating system, or bootstrap loader is the first program that will work when your system is turned on or restarted. The third one was relocatable loader. We have already discussed about 2 computers, that is SiSi and SiSi-XE. In SiSi-XE, we have learned the concept of relocation. Here, for that, format 4 instruction which will be modified. While modifying a format 4 instruction, we are writing modification record. Here, you will write M, then you will write the location which will be modified, how much bits are modified, and along with that we will write the name of the program. Second one was, we have discussed about the SiSi-XE program. SiC program, actually in SiC program there will be no modification, but it will contain relocation. For relocation, we are using a new concept called as bit mask. Bit mask will be identified if a object code will have a bit that will be modified, I will specify as 1, and if the object code does not contain, or if the object code does not point a memory location, for example, if your object code will point just a word, then it will not be modified. So if an object code points to a memory location or label, then that content will be modified. Otherwise, that content will not be modified. If you are modifying a content, you can specify by means of 1. If you are not modifying a content, or if your content cannot be modified, then you will specify as 0. For example, you can see an instruction called as rsub. So rsub will have the value 4C, and again it will specify it as 0, 0, 0, 0. This will be, wherever you run the program, this will not be modified. If an instruction which will not be modified with respect to a memory location, then we can specify that will not be modified, you will specify as 0. So for this we are using a bit mask. Bit mask is a 3-bit, and each bit can have the maximum value of F. That means all bits in that value will be 1, 1, 1, 1. So we will have a total of 12. So we already know that a text record can have maximum of 10 records. If all the 10 records can be modified, then you will have first 10 bits will be 1. That means F, and the last 4 will be, the first 2 bits will be 1, the remaining 2 will be 0. Then you will have F of C. Then if you don't have a text record, or if you have a text record of limited size, the width mask will vary. So this is about the loader concept. Hope you understood the lecture. Thank you.